All right, we're going to go over problem number 34 from the 2017 geometry exam that was given in January. All right, so let's read this question. It says a candle maker uses a mold to make candles like the one shown below. The height of the candle is 13 centimeters, and so we're talking about this part right here, 13 centimeters. And the circumference of the candle at its widest measure is 31.416 centimeters. Use modeling to approximate how much wax to the nearest cubic centimeter is needed to make this candle. Justify your answer. All right, let's go and look at something here. I'll look at a couple of things. First of all, it says the height of the candle is 13 centimeters. And the circumference, it's hard to do circumference, but that is kind of all the way around it, if you can imagine that, at the bottom. Imagine a cone. You have to know that this is a cone, for one. So we're talking about a cone. Also, when it says how much wax, you have to think about what a mold is. You actually pour something in. And so you have to figure out, well, what are we talking about, area or volume, or maybe surface area? When you're talking about filling something up, you're always talking about volume. So when it says how much wax, that might not be enough, but nearest cubic centimeter, this word cubic, that tells you definitely you should be doing volume at some point. Okay? So I need you to write down the volume of a cone, which is this. All right? The formula for the volume only requires having the radius. The problem is we don't have the radius, but we do have the circumference. And we have, I want you to write down what the definition of circumference is. That's the distance around the circle. So again, when I did this, imagine a cone, and a cone has a circle at the bottom, the widest part, that's the circumference. Okay? Now, the formula is here. Now, typically when you're dealing with circumference or a lot of formulas, you're given, well, let's talk about circumference. You're given the radius and you have to find the circumference. But in this situation, in order to use this formula for volume, you're going to need to have the radius. Well, the only way to get the radius is to use the fact that they actually, in this case, gave us the circumference. So we're actually going to plug that in, and you're going to get 31.416 is equal to 2 pi r. All right? Now, what you're going to do at this point is divide by 2 pi, put that in your calculator, and what you're left with, so that'll be 1 over there. So really what you have is 31.416 divided by 2 pi is equal to r. All right, so let's go ahead and put that in the calculator. So I'm going to do my fraction, alpha y equals enter. All right, and it's going to be, what is the number again? 31.416, so 31.416 divided by 2 pi, enter, and you get approximately 5. Actually, if you round that even to the nearest 10,000th, you'll get 5.0000. So we can just say that that is 5. So we're going to write r is approximately 5. I would say if you do this, you'd get 2 out of the 4 points, I would say, most likely. But to get the other 2 points, you're going to have to go ahead now and plug this value in here. All right? So your volume is going to equal 1/3 times pi 5 squared. Now it says to the nearest cubic centimeter. So you're not going to round to the nearest 10th or 100th. It's going to be to the nearest whole number. So let's go ahead and put this in. You know, sometimes they actually will say in terms of pi. In this case, they don't. So So you're not going to want to have pi in the answer. We're actually going to put it in the calculator. And you end up with 26.1. Let's go ahead here and see something here. Yeah, I forgot something. Think about what I forgot. Or maybe you know, maybe you already saw. And what number have we not used yet? We have not used the height. So, that's what I forgot. So I need to take this and you need to change this and put in the h. All right. There we go. So I need to multiply in the height. Knew something was wrong there. All right, so that's going to be times 13, which is the height. So I'm going to go back and put this, and then times 13. That looks more like it. All right, so our answer is 340. So V is approximately 340 cubic centimeters of wax. All right, when it says justify your answer, all of this work that you showed, would be justified. All right? So there we go. Okay, moving on to the next problem. There are two questions on part 4. Each of them is worth 6 credits, right? All right. So, first one we have is a proof. So let's read about this proof, what we're trying to prove and the information we are given. So we have in quadrilateral A, B, C, D. So we know it's a quadrilateral, which is pretty obvious from the picture, but it doesn't say it's a parallelogram. All right, it says AB is congruent to CD. So I'm actually going to start marking these a little bit here. So we know those are congruent. And AB is parallel. Remember, that means parallel. So I'm going to make a little mark for parallel, so they're congruent and parallel. And BF and DE are perpendicular to diagonal AC. So BF is this one. So that means perpendicular. That means that this is a right angle. And that means that this is a right angle. And also for DE, same thing. All right, perpendicular to diagonal AC at points F and E. Prove, now that we always want to keep track of what we're trying to prove. We're trying to prove that AE is congruent to CF. All right. Now, there are a number of ways to do this, but the way I'm going to go about, I'm actually going to prove that these two triangles are congruent, okay? And once I do that, I'll be able to prove that these corresponding pieces of congruent triangles are congruent. If you remember C, P, C, T, C, if you can figure out, if you can prove that two triangles are congruent, you can say that the corresponding parts of those triangles are also congruent. All right, so a couple things we're going to need to know. First of all, what 5 ways did we learn to prove triangles congruent? Remember the SSS, SAS, so we have side, 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 we have side, angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. All right, we're actually going to go and use, well, we'll see it when we get there. We'll see it when we get there. Now, very important fact that you need to write down, and if you didn't know this, it made this problem much more difficult. In a quadrilateral, if two sides are both congruent and parallel, it must be a parallelogram. So the fact that what they told us about this shape is that it's quadrilateral, which means we cannot use any of our properties of a parallelogram. Remember all the properties of a parallelogram we've talked about? You've written down, if you've been going over this test all along, the opposite sides congruent, the opposite angles congruent, the opposite sides being parallel. All these properties that you know about a parallelogram can be used if you know it's a parallelogram. Well, we know that if two sides are both congruent and parallel, it must be a parallelogram. Well, we have that because A, B, and C, D are both congruent and parallel. That means that this is a parallelogram, which means all the properties of a parallelogram you can use at this point. Okay? So, now,
teachers, if you have any extra phones, please bring them down to the information booth. Again, teachers, if you have any extra phones, please bring them down to the information booth. Also, the cheerleading meeting for today has been postponed until tomorrow.
all right. So as you see right here, I wrote down the given information. You always want to write down the given information, and we want to look at how we're going to use it. So let's see. So the first thing I'm going to say, after you write down the given information, I'm going to say that quadrilateral ABCD is a parallelogram. You probably get a point just for this. Remember, this is a 6-point problem. And how do we know that? Well, we just talked about it. Two sides are both congruent and parallel, making it a parallelogram. All right, so we know it's a parallelogram. So based on that,
The health and PE teachers, if you have any extra phones, can you please bring them up to the information booth? Again, the health and PE teachers,
All right,
if you
I'll
have
do
any
that.
extra.
all right, let's keep going on this proof. All right, now we have established that this is a parallelogram. And let's use some of our given information now. Let's focus on our triangles. We're trying to prove congruent. We already have two sides because we have AD, not two sides, a pair of sides. So we have AD and CB are congruent. That's a side. So we already have a side. We already have, well, we don't have an angle yet. We do have an angle, but we have to say that we have the angle. We have this angle, and we have this angle. So angle CFB and DEA. What I'm going to do is name this angle 1. So I'm actually going to put a 1 here and a 2 here. And down here, what I'm going to write now is angle 1 and angle 2 are right angles. And how do we know that? Because the definition of perpendicular. All right? And we can also say, okay, let's go to the next part. Let's see. All right, so now we have angle 1, angle 2. So we have a side, we have an angle. All right? Now, if you remember, if you recall, when you have two parallel lines, these are parallel. It's already told us that in the given information. When you have a third line going through, you have alternate interior angles whenever you have a parallelogram. So I'm going to name this angle 3 and this angle 4. And you could say angle 3 is congruent to angle 4. All right, angle 3 is congruent to angle 4. So I have all these colors going, but hopefully you can follow it. So I'm going to write now angle 3 is congruent to angle 4. And my reasoning is going to be alternate interior angles congruent when two parallel lines intersected by third line. Intersected by, I'll say a transversal. I'll use that vocabulary. All right, so now we have an angle. We have angle, and then a side. So let me get something here. So if you look at this triangle, we have this angle, congruent. We have another angle, congruent. What did I just do? You know what? I just showed the wrong angles. Sorry about that. Let me take this away. Let me start this. First of all, 3, hopefully you notice this, 3 should be there, because remember, you have the Z. Actually, no, I need to do something else also. It's really talking about these lines All right, I gotta take a break for a second, make sure I'm going the right direction here. Okay, I'm back. Yeah, what you have to focus on are these lines actually, and you have more colors here. You have the Z, remember the Z? So it should have been this angle in here and this angle over here. Okay, so angle 3 and angle 4. All right, so now we actually have angle, angle, side, right? We have an angle, we have another angle, and we have side. You could also say SAA. It could be angle, angle, side, or side, angle, angle. Either way, but we have enough to say that those are congruent, those two triangles. So we can now say that triangle AED is congruent to triangle CFB, and we can say that because of angle, side. Now that's not enough. Now we need to say that these two corresponding parts of those triangles are congruent. So let's do the last part. 6 AE is congruent to CF. And my reason is CPCTC. Remember, that stands for corresponding parts of congruent triangles are congruent. All right, so that's the end of that, and hopefully you didn't get too confused on that, and you were able to follow along.